Okay, so we want to deal with integrands of the form a square minus x square, a square plus x square, and x square minus a square, where we take a positive so that this makes sense. Okay, so let's start with the first type. So let me check what I did here. Okay, so I did these types separately. Then I did these things, and then we'll have a quiz. Okay. So let's have first type, this one, a square minus x square. Okay, I'll only do this part, integral a square minus x square dx. Okay, so how many? The two types of trigonometric identities we have are, okay, so let's keep these things in mind. So what do we have? Sine square x plus cosine square x equals 1. And then what? 1 plus tangent square x equals secant square x. Okay. So for the moment, suppose a is 1. So we are looking at 1 minus x square. So 1 minus sine square or 1 minus cosine square will work. 1 minus secant square will not work. Why? We also have a formula for 1 minus secant square. Why will it not work? What is 1 minus secant square? Minus tangent square. So it's definitely negative. We don't want to talk about the square root of negative things because we are too young for that. When you grow up, you'll find that square roots of negative things also exist, but don't get involved in that yet. You are, but you are not 20 years yet, right? Okay, so this is after you are 20. So for this thing, this is our only chance. Okay. So for this thing, put here. Okay, so I'll continue. I'll do a few calculations. So without putting here, put x equals a sine theta. Okay, so sometimes these things are called inverse substitution, sometimes trigonometric substitution, because we say set theta equals arc sine x over a. Okay, that's inverse substitution. Okay, so when you do this, you have dx equals a cosine theta d theta. Okay. So we want these things to be positive. So you can say let theta be between minus pi and plus pi, minus pi over 2 and plus pi over 2, so that this will be positive. Okay, so let theta be less than pi over 2. Okay, so this is so that cosine theta is positive. Okay, so in these inverse substitutions, or as the book calls them, trigonometric substitution, the mechanism is just straightforward. You just play with trigonometric identities, but when it comes into the last stage where you have to evaluate something, you have to check in which domain you are so that you don't want to deal with negative square roots. Okay, so here we took care of that here. Okay, then we look at a square minus x square. This is equal to a square minus a square sine square theta. So this is 1 minus sine square is cosine square, so this is a square cosine square theta. Okay, and I want to take the square root of this, a square minus x square. Then it becomes the square root of this. Cosine theta is positive, a is positive. Okay, so we are assuming that. So this is a cosine theta, and that is what we have. Okay. So this thing will contribute a cosine theta. Okay, so this is the, I got rid of the square root here, and dx will give me another cosine theta. So I'll be integrating a square cosine square theta. Okay, so let me do over here. Okay, then I have I equals integral square root a square minus x square dx. It now becomes a square. I take a square out, integral cosine square theta d theta. Okay, I can easily integrate this. Remember, a square integral 1 plus cosine 2 theta over 2 d theta. So this is a square theta over 2 plus sine 2 theta over 4 plus constant. Okay? Everybody agree with this? I'll continue from here. If it is wrong, it's totally your responsibility. You are checking. Okay, correct? Okay, so I got one I got one approval, so I continue. Okay, but you see this is correct, but this is not yet the answer we want to give because the question is in x. So we have to now change the thetas into x. For this, we do the usual thing. We construct, okay, so to change theta answer to an x answer, we consider the usual right triangle. Okay, so that right triangle is here. Okay, so we have this right triangle about right triangle of x equals a, what did I say, sine theta. Okay, so I have this right triangle. This angle is theta, and its sine is this side over this side. So this is x, this is a, and here I have a square minus x square. Okay, so this is, you have to obtain this integrand somewhere there.
Isn't this a cos theta?
What? Here? Where? Here?
A square cos square theta.
Yes, a square cos square theta. Huh?
But we found a cos theta.
You find a cos theta, but dx, I have dx here. Okay, so I have this thing. Okay, so I have this thing and this thing. Okay? Mm-hmm. Okay, so here, now we have to undo this. Okay? I can talk about sine theta, but instead of sine 2 theta, let's make this easier. A square theta over 2 plus, this is 2 sine theta cosine theta, so sine theta cosine theta over 2 plus constant. Okay, so here I know what sine theta is. Sine theta is equal to x over a. Cosine theta is a square minus x square over a. And I need theta. Okay, so theta is arc sine x over a. Okay, so now I put these into the expression. So put these into the expression. Integral I denoted this, becomes a square. Theta is, so 1 over a times arc sine x over a plus 1 over 2 times sine theta is x over a plus times cosine theta, which is square root a square minus x square divided by a plus a constant. Okay, so you can stop here, or if you want a little bit more cosmetics, you can multiply this by a. So you will have a arc sine x over a plus 1 over 2 x square root a square minus x square plus c. Okay? So that takes care of the type a square minus x square. So in the exercise in the book, you will see that generally you have some x's here and denominator, etc. Okay, so you use the same substitution and check if it works or not. Okay, so let us look at the second type. So for this type, you see this one is suggested because you are adding, you can look at a as 1. So we have 1 plus tangent square. And for this one, you see you can take 1 to the other side. You have secant square minus 1. So for the last two, we'll try this one and see if it works. Okay, so now we'll look at the type a square plus x square. Okay, here try putting x equals a tangent theta. For this thing to make sense, we want theta to be theta less than pi over 2. Okay, so that tangent doesn't become infinite. I deliberately put try here because these things, integration means you try. Okay, there is no, you don't generally look at this and say immediately this will work. Okay, even though it looks like the type of problems you solved previously and something worked for all of them, it doesn't guarantee that it will work here. So you try. If it doesn't work, you don't lose courage. You go back, you try something else. Okay, so here we try this. Then dx becomes a secant square theta d theta. And a square plus x square becomes a square plus a square tangent square theta. So this is a square secant square theta. Okay. So here in this range, for theta less than pi over 2, cosine theta is positive. So secant theta is positive. Therefore, when I take the square root of this, I will have positive secant theta. Okay, so let us start with this integral a square plus x square dx. This is equal to, when I put these things in, so this thing becomes square root of a square secant. So this is a secant theta. And dx was a secant square theta d theta. And we have this famous integral a square secant cube theta d theta. Okay, I'll show you in a minute how this thing is integrated. This, you see that this comes up very often. So the formula, okay, so here later, it turns out that this is, I forgot a square. So this is a square over 2 secant theta tangent theta plus ln absolute value of secant theta plus tangent theta plus c. Okay, so I'll show in a minute how this works. Okay, so here again we are in the same situation. We found the correct answer, except that we have to prepare it for this x setup. Okay, so now consider the triangle. Okay, so this is theta. This is a, this is x, this is a square plus x square. Okay, tangent theta is this over this, so that's what we had here. Okay, and we know tangent theta is x over a, and we need just secant. Secant theta is this over this. Okay, so this is a square plus x square over a. Okay, so then I can write I as a square over 2. So I have here secant times tangent, so I just multiply these things. X, a square plus x square divided by a square plus ln of these guys. Okay, so this is secant theta is a square plus x square over a plus x over a plus c. You can simplify this. You see a square multiplies this, so let us simplify this. This is 1 over 2x a square plus x square plus you see I have a square over 2 ln of this minus ln a is a constant, so we can get rid of this. Okay, so a square over 2 ln a square plus x square plus x plus constant. Okay, so here you see I have minus ln a, but minus ln a I just tell c to deal with it. So this is the answer. Okay, so let us look at the other type, and then I'll look at the second integral. Square root x square minus a square. Okay. So here try x equals a times secant theta. Okay. Then dx is a times secant theta tangent theta d theta. And x square minus a square becomes a square tangent square theta. Okay, so since I'll take the square of this thing, when I'm taking the square of this thing, if it's a definite integral, you must check on which intervals tangent is positive, on which intervals is negative. So when you write the square root of tangent square as tangent, you have to put in the correct plus or minus sign. But I'll assume now that it is positive, and I'll continue like that. Then the integral I have is the following. Again, let's call this the integral x square minus a square dx. Okay. Okay, so I'm taking the square of this. I get an a tangent. Okay, so let me write this here. X square minus a square is equal to a tangent theta when tangent theta is positive. We are assuming that a is always positive, so let me remind this. So a tangent theta comes from here, and then we are multiplying with this. So a square comes out. Integral, I have secant theta tangent square theta d theta. Okay, so I can write tangent theta as a square integral secant theta. Tangent square is what? Secant square theta minus 1 d theta. Okay. So we have a square secant cube theta d theta minus a square secant theta d theta. Okay, so you see there is no way out of these seconds. So let us see how we. So here we know how this is done because we just copied it from the book. But how do we do this one? Okay, so I'll leave it here. Okay, so here. Okay, so here I'll leave it. Now we pass to doing secant cube and secant. You know, let us start with secant theta because secant cube needs secant theta. Okay, with secant cube, we'll do integration by parts, and then we'll solve it. Okay, so we need to know integral secant theta d theta. Okay. So we do a substitution here. Okay. So that's called the world's sneaky substitution. This is where. Okay. So we use the world's okay. So this is how it goes. You have secant theta d theta. When no one is looking, you do the following. You write secant theta plus tangent theta divided by secant theta plus tangent theta d theta. Okay? You just do this. It's correct. Okay? And then you say, let us multiply these things. You have, let me multiply it in this order, this times this. Secant theta tangent theta plus secant square theta divided by secant theta plus tangent theta d theta. So when people ask you why you did this, you say, but it's easy. Look here. If I take the derivative of this, I get this. Okay, derivative of secant theta is secant theta tangent theta plus derivative of tangent theta is secant square theta. Okay, just like magic. Okay, so here put u equals secant theta d theta plus tangent theta plus tangent theta. Then miraculously du is secant theta tangent theta plus secant square theta d theta. Okay, so this is what you have in the denominator. This is what you have in the denominator. So the integral becomes du over u, and this is equal to ln absolute value u plus c. Okay, so the answer is ln absolute value secant theta plus tangent theta plus c. Okay, just like magic. All you have to do is multiply it by 1. Okay, so we multiply this by 1, and then everything fell apart. Okay, now we use this. We use the value of secant theta to find secant cube. So let me do secant cube. Okay, so now using this, we can attack integral secant cube theta d theta. Okay, so there we must use integration by part. Okay, so let us look at this. Let us call this integral secant cube theta d theta. Okay, now I'll use integration by parts. So try integration by parts by u equals secant theta and dv equals secant square theta d theta. Obvious splitting because I know that secant square is derivative of something. Okay, so on this part you try to write something which is derivative of something that you know. Okay, so du becomes secant theta tangent theta d theta, and v is tangent theta. Okay, so now let us put these in here. I multiply this and this, so this is secant theta tangent theta minus minus this part. Okay, so integral secant square theta tangent theta d theta. Okay, it looks hopeful because we were dealing with secant cube. Now we have secant square. Question? Which one? Yeah. Well, it's even better. We were trying to get, we were trying secant cube. Now we have secant. Okay, so let us try to see what we can do with this one. So this one is, okay, I'll keep the minus sign out. This is secant theta, but tangent square is what? Secant square theta minus 1 d theta. So this is equal to integral secant cube theta d theta minus integral secant theta d theta. Okay, so I know this one I called I. Okay, so what we have is that here this is now equal to secant theta tangent theta minus I and plus integral secant theta d theta. So this thing we know, this is equal to ln secant theta plus tangent theta plus a constant. So this comes with a plus sign, ln secant theta plus tangent theta plus an integration constant. Okay, so I take I to the other side. 2I is equal to this expression. So solving for I, from here we get, okay, so I comes to this side. I have 2I equals to that expression. So I is equal to 1 over 2 secant theta times tangent theta plus 1 over 2 ln secant theta plus tangent theta plus integration constant. Okay, so this is how these things magically fall apart. Okay, so I have this. So how about we integrated secant cube. How about tangent cube? So let me ask that to you. Let's take a few more. So you solve this, then we start the quiz. Okay, so we dealt with secant cube. How about tangent cube theta d theta? You see, they are friends, so if you do one of them, you must be able to do the other. Okay, so what ideas do you have for this?
We can write as sin over cos. So that
Yeah, but then you have sine cube over cosine cube.
then we sin
But then,
sine.
yeah, that should work. Okay, so that's working. Okay, that's a correct idea. That works. And then when you simplify, you'll be surprised that it simplifies down to something very simple. Okay, another idea. Let's use trigonometric identities here. We know tangent square is equal to secant square minus 1, right? So let us write that. Tangent theta is secant square, secant square theta minus 1 d theta. So what happens? This is equal to integral tangent theta secant square theta d theta minus integral tangent theta d theta. So is tangent theta secant square theta the derivative of something? It is the derivative of something. Immediately when you look at it, you should see that it is the derivative of something. I heard the correct answer, but at such a small decibel that not even the camera heard it. Up? Tangent what? Derivative of tangent is secant square. And
if we say u to tangent.
no, before that, you should immediately see that this is the derivative of something without going any further. You have one part of it, yes? Tangent square. Because tangent square, okay, 2 comes down, you have tangent, that tangent is there. Then by chain rule, you have secant square, so it is there. Okay, so this thing is, well, so what do I have? 1 over 2 tangent square theta. If I take the derivative of this goes tangent secant square, I have this. Minus, what is tangent theta? So now we use your idea. This is ln of cosine or sine, ln of cosine, right? But it must come with the plus sign because when you take the derivative of cosine, you get minus, okay? Plus ln of cosine theta plus constant, okay? So tangent was much easier. Tangent cube was much easier than the secant cube. Okay, so that's all for these trigonometric substitutions. Now you'll have your quiz.